Hello SGD. This will be a compilation video of some of the earlier videos I did in regards to the 1 second 1 meter pendulum and how this timekeeping device pendulum relies on the length of the pendulum, gives you the period of time at which it covers. There's a nice connection even to the Templar cross there as well. But this will be a compilation of some of the earlier videos looking at the 1 meter pendulum, how it connects to the Royal Egyptian Cubit. 1 second is of course 86,400 seconds per day, which is a very interesting series of connections to many other features including the planets. Again, this will be a compilation of older videos. I've added a few little bits in between, but basically it's just the older videos before I do a full revised version with all the other applicable information, setting up this symphony of coincidence in regards to not just the meter, the second and the Egyptian Royal Cubit, but also to the imperial system, the older, the proto-meters, which was the original meter, was going to be based on a 1 second pendulum. That was almost the unit of measurement that George Washington and Thomas Jefferson were going to introduce to the US, and also those connections to other ancient units of measurement such as the foot used in Mohenjo-Daro, the ancient Indus civilization, which later became the Saxon foot, but also sometimes referred to as the Sumerian foot. But using known ancient units of measure and also geodetic data, the size of the earth applied to sacred architecture, the harmonics embedded in these systems as well. Just a beautiful series of mathematics, including pi over 6 meters being one Egyptian Royal Cubit, pi over 6 being the ratio of size between a sphere inside. If the cube has a volume of 1, the sphere has a volume of pi over 6. So there's a whole series of connections, and I'll put this up as a compilation before I do the revised version. And again, it's known units of ancient measure based on maths, based on earth measure data as well, and the best survey of ancient architecture connections even between larger sites. So that'll be in the extended fuller version, because it's not just about the Great Pyramid, it's about the larger Giza plan, the relationship to Heliopolis, and even further than that. It really just is. It's a symphony of coincidence.
Hello SGD, Sacred Geometry Decoded. This will be extension of the series. I did some pendulum work before, but we'll be looking to, I'll be showing you a series of connections. So basically we're talking about measurement. Okay, now an important feature of measurement, measuring weight and measuring length, is also measuring time. And the measures of length actually comes from the measure of time. So I've set up 3 pendulums here, and we'll be looking at the measurement of 1 second. So let's begin with the middle pendulum. I have this rod, so that's 1 meter. Okay, so what we have here is a pendulum which is 1 meter. To the center of gravity, the pendulum length is 1 meter. So this ribbon is very light, so basically, so all the weight is held here. So the center of this pendulum is on this section of arc. Now, prior to the 1920s and 1930s and the quartz crystal, and then later developments in timekeeping, the pendulum has always been how to measure time. And consider the ancient Egyptian plumb bob, etc., which was also called the horologium, or the Temple of the Winds in Athens, which was a timekeeping temple. But let's first, as an example, so, okay, before I also go on, all these pendulums are set at 30 degrees. This is not an arbitrary angle. This was calculated centuries ago. Giovanni Battista Riccioli, for instance, just like a grandfather clock, it has to be at a shallow angle. And actually 30 degrees is the cutoff point, because with this pendulum, as it swings, so it's very slight, but the rope or the string will bow a little bit. Now this, as long as you stay below 30 degrees, you're quite good. Now the same principle would be if you're on a children's swing when you were young. If you go up to a certain point, you don't swing down in a solid arc, you sort of go up the chain gets a little bit loose, and then you fall down. So that's why it has to be at 30 degrees. Again, this is not arbitrary. This is a well-established piece of information. So as an example, no more than 30 degrees. 1, 2, 3. We're going to keep 1 second. Now, over time, this is going to lose, and it's going to eventually slow down. But even from the longest part of the arc to the shortest, it's always going to keep 1 second. This particular pendulum is based on 1 meter. Over here, I have another pendulum which is at 0.994387 meters. So it's 1 meter minus 5.6 millimeters. This pendulum, developed by Marin Mersenne in 1640, is 1 second at 30 degrees, at 45 degrees north of the equator. So halfway between the equator and the pole, this is the pendulum to get 1 second. The further you move away from the pole to the equator, it changes timing. So even though these pendulums have a slight variation, at a point on the Earth they will be correct, and that's another very important issue. But this was the well-established pendulum. This pendulum of 1 second was going to become the official US standard of measurement for length. So the US foot was going to be 1, 2, 3, or a yard. 3 feet is a yard. This was going to become the US foot. George Washington, Thomas Jefferson almost brought this in, but instead they stayed with the 12-inch English scale. Okay, now back to this pendulum. So 30 degrees at exactly 1 meter. It's exactly pi over 6 meters, or 1.7178 feet, which is a fraction of a hair from E minus 1 feet. But that same measure is 1 Egyptian royal cubit, as used in the pyramids. So 1 second, 1 meter, 1 cubit joins nicely. However, this pendulum of 99.43787 millimeters is 5.6 millimeters shorter than this one. So 3.262, etc. feet. This one is 3.2808 feet. A difference of 5.6 millimeters. Here we have the Egyptian royal cubit, from your elbow to the tip of your finger, which is this section of arc here, pi over 6 meters. The Egyptian royal cubit was divided into 7 palms, 1, 2, 3, 4, 5, 6, 7. 1 palm, or 4 fingers, 1, 2, etc. Now, if you can look at the Vitruvian Man illustration, the length of your foot is pretty much equal to the length of your elbow to your wrist. So we could call this the Egyptian foot. The Egyptian foot is 0.299199 meters, or 29.91 centimeters. The English foot is 0.3048, or 30.48 centimeters. The difference between let's just call it the Egyptian foot, or the Egyptian forearm, is 5.6 millimeters. The difference between the modern meter and the 1 second pendulum at 45 degrees north is 5.6 millimeters. While we're on that topic, okay, so therefore the cubit, or the arc, is 52.066 centimeters, or 0.52066 meters. That's 1.7082 feet, or, 27.3312 fingers. So an inch, 12 inches equals a foot, or a thumb, 1, 2, 3, but also 16 fingers equals a foot. So that's fingers, also called digits, which just happens to be 1.000899 Samian cubits, which brings us back to the Salamis stone. I'm just making this particular video because I want to use these points in a follow-up. Okay, so we have 1 second at 45 degrees north of the equator. I'm currently in Sydney, Australia, basically 33 degrees south of the equator, so we would have a different pendulum here. But the 1 metre, the official 1 metre, which is now based off the speed of light, so you can call that the speed of light metre. There's an extra little bit on there, so that's 1 metre, gives us the Egyptian Royal Cubit, or E minus 1 feet. 1 second, 1 metre, 1 cubit, also linking to feet with these beautiful numbers. 27.33 fingers, or a Samian cubit within, again, a fraction of a hair. So we have, I'll just get these two pendulums started again. 1 second pendulum at 45 degrees north almost become the basis of the US system of measurement. The modern 1 second pendulum, which gives us the Egyptian Royal Cubit, 86,400 beats per day. Okay, now I have another pendulum here. This one is 3.3 imperial feet. So 3.28. This is 3.3 feet, or 1 metre and 5.84 millimetres. 5.84. The difference between this one and this one is 5.6 millimetres. So the difference between the foot and the Egyptian forearm is 5.6 millimetres. That's the difference between the length here and the length here. If we add 5.6 to the 1 metre, where we would get 1 metre, 5 millimetres and 6. So we're a difference of 0.24 millimetres. 1/4 of a millimetre, which is essentially 2 human hairs. It's ever so close. Now what's important about the 3.3 feet is that prior to the modern English scale, we had what was called the Saxon or the Northern foot, which was at 1.1. So therefore, this pendulum is 3 Saxon feet. And interesting point, the Saxon foot is exactly the same as the ancient Mohenjo-Daro foot from Mohenjo-Daro, Harappa, or the Indus civilization. So 3 Mohenjo-Daro feet. Mohenjo-Daro is at 27.3 degrees north. Okay. So we have this is called the Indus Scale, which is essentially the same 5.6 millimetres plus a metre, gives us this to within 0.24 of a millimetre. This would also create a very accurate 1 second pendulum. The length of this arc would be exactly, by definition, pi over 2 Mohenjo-Daro feet. Okay, but that's just the way things work. But that's 0.52665 metres, or 1.727859 feet. The canonical cubit put forth by Jean-Michel and John Neal is pi over 6, not pi over 6, 6 over 5 cubed. So 6 over 5 cubed equals 1.2 cubed, which is 1.728, a number ever so important to New Jerusalem, also the Ark of Nakishtim in the Epic of Gilgamesh. Again, the difference between this arc and the precise canonical cubit is 40 microns. The thinnest of the thinnest human hairs is the difference. So now the difference is 2 10,000ths of a foot, minuscule. This will be an important unit because this unit, which comes from Mohenjo-Daro, the Indus civilization, giving us an accurate 1 second pendulum, the allegedly modern metre, which pendulum gives us E minus 1 feet, or pi over 6 metres, and the Sam, or the George Washington, Thomas Jefferson 1 second pendulum at 45 degrees north. 1 metre minus 5.6 mils gives us this. 1 metre plus 5.84 millimetres, a fraction, 1/4 of a millimetre gives us this pendulum. This pendulum, this and this one we'll be focusing on because this is going to give us answers to the size of the Earth in relation to the size of the Great Pyramid, and also another example of a relationship between the Egyptian royal cubit and the modern imperial foot. Margins of error in these systems brings us to profound knowledge. Instead of rounding off, you look at the, well, you get the, we'll see, and I'll cover this in the follow-up videos. I just wanted to make this animation, this video to demonstrate the point. And just as a reference, because in the next videos I'll just be using still frame information. But as in the previous episodes, 27.3, talking about the Great Pyramid, and all ancient architecture embeds this particular number. The modern 1 metre, with the double vesica, which also incorporates synodic, sidereal months, and other important features in there as well. So, Thoth or Shesset, gods of weights and measure. So if you see the old pictures of Thoth or Shesset, they have a palm branch, and they've cut the notches. So again, as an accounting tool, but also as a measuring tool. Across civilizations, even for instance in biblical scale, the measuring rod or the wand, as in the caduceus of Hermes, these gods of knowledge, of astronomy and architecture, both Shesset, Ningishida, Hermes / Mercury, Nuar and Thuzi, are all gods of weights and measure. They're the gods of science. And this information and the connections between these provide a very important feature. Now, why is timekeeping? Firstly, measuring length gives us a measure of time. Why is timekeeping so important? Well, the METRE pendulum of 1 second, one of the reasons for this development, and like especially with the Jesuits and people connected to cathedrals, was to essentially to create a metronome for timekeeping for music. The development of this was actually the people working on it would work with choirs to try and get the perfect definition of time. 1 second, I would suggest, is not a completely arbitrary unit of measuring time. There is something to this, and that these different units, which I've already shown in previous videos, which connect so wonderfully to whether it's New Jerusalem, as described in King James Bible, but also the Ark of Utnapishtim, which incorporates all these lovely systems and blends back together at these very important, very harmonic geometric numbers. These are mathematical geometric constants, because E, which is so, it's so important, E minus 1 is very, very close. It's a fraction, it's the smallest human hair difference between E minus 1 feet. And this meter second cubit relationship, the imperial foot, and these margins of error between these providing profound, measurable, tangible, geometric, mathematical information, which can be then connected to the architecture itself. And also in ancient letters, so whether it's the Yugas, 86,400 seconds per day, 1,440 minutes per day, or 144,864, 1728. These are all the numbers which are embedded in legend. And once you apply this Hermetic knowledge to the ancient architecture as well as to modern architecture, what we have is a beautiful set of coincidences. Now, not just keeping time is important for music. The applications for this would be measuring units of work, but also, for instance, alchemists or the ancient chemists. They would need to transmit that information. For how long would you, mix chemicals together? How long do you blend things together? It's a very important thing, this knowledge for even modern science. And well, this was the way to do it until the 1930s and the quartz crystals. And it's still super, super accurate. And via the Hermes, Thoth, Shesset, weights and measures knowledge, once again we see just a symphony of coincidence which brings all these things together in a very measurable, practical way, which brings us back to geometric mathematical constants which have been constant since the beginning of time and timekeeping. I could get, okay, this is a 1 meter, okay, but now I could just set this arbitrarily. I say, okay, I'm the king, this is a unit of measure we're going to use. It can be set arbitrarily. Well, now it gets more complicated because when you talk about weights and measures and timekeeping, okay, so yeah, what I mean is that I could just set any unit, okay, but to make a pendulum, it's not that simple, because if you shorten the pendulum, the frequency changes. So now it's less than a second. You know? Now here it's going to be longer. It's going to be a second. So all these, this is still essential knowledge for our civilization, our culture, for our sciences today, is to keep units of measure working together, same numbers. And the extraordinary thing is not just the closeness of it, but the fact that margins of error between these incorporate essentially the knowledge you need to blend other bits together. This, my friends, is no mistake. This is a genius system that they've done to include a flexibility into the system. Example would be to use the Fibonacci numbers to create phi. What you have is it creates a wave. Now that wave is going to get shorter and shorter, and it's going to come closer to it. So what we have is margins of error there. I want to cover this in the future, because even the difference from phi gives you knowledge on the golden number, which will blend all the way back into these second pendulums, 1 meter, or the Saxon or yards. And yeah, so I'll link previous episodes in the description. I'll also put the full series in there, because if you want to know about it, you have to see the whole thing, because it's not just a couple of, maybe this is an accident margin of error, but when you look at the whole series and blend all these geometric, mathematical facts back together to ancient weights and measures, to say that there's proof is a strong word, but to say that there's nothing there and to dismiss it as coincidence is a pathology, to be frank, because it's really up to the skeptics to provide a system to explain these coincidences. I don't think at this point I don't need to prove. I've established my body of evidence, I've established my case, and now it's up to those who would say otherwise to provide some explanation of how all these architectural, metrological, mythological elements all blend perfectly together. Measure. Hello SGD, I'll put the link to the video I posted yesterday, which was based on these 3 types of pendulum. So very quick review. 1 second. So how to measure time in a consistent, like a wave that could be transferred and be accurate. And it has always been the pendulum up until 1930s and quartz crystal. This pendulum is 0.994387 meters. This is the pendulum, the 1 second unit at 45 degrees north of the equator. As you move north or south of the equator, because of the variation between gravity, you have a slight variation in the length of the pendulum. So if you're at Paris, basically 45 degrees north, this was the 1 second pendulum. Of course, as mentioned earlier, the shallow angle of 30 degrees has been established as an important feature. So 1 second pendulum, this was going to be introduced as the American, so 1 American US yard almost became this pendulum, actually based on the second. It never quite come about, but that was the important feature. Okay, so that's a 1 second pendulum at 45 degrees. It changes ever so slightly depending on your location. This pendulum is exactly 1 modern meter long. This is called at the speed of light meter. At that 30 degree section of arc is, by definition, it has to be pi over 6 meters, which is 1 Egyptian royal cubit, which was the unit of measure used in the construction of the pyramids. One Egyptian rolled cubit, so 52.3 centimeters, was then divided into 7 palm or 4 fingers, so 28 fingers or 4 palm. As in Vitruvian Man, the foot and the forearm correspond, and so one Egyptian foot, let's call it, is 29.9199 centimeters. One allegedly modern English foot, 12 inches, is 30.48 centimeters. A difference of 5.6 millimeters, which is an important feature because 1 meter minus 5.6 millimeters equals this pendulum here. And I also mentioned the Saxon yard, which was equipped. So one Saxon foot is 1.1 of these, 13.2 inches is a Saxon foot, which was used before this was introduced, which is exactly the same unit of measure, some even suggesting Sumeria, but the Mohenjo-Daro or the Indus Valley. This too would create a very, very accurate pendulum. So the difference between the English foot and let's call it the Egyptian foot, 5.6 millimeters. 1 meter minus 5.6 millimeters gives us the modern definition of a meter at 45 degrees. 1 meter plus 5.84 millimeters. It's a difference of 1/4 of a millimeter is the difference between those there. Now that would make this arc slightly longer, which turns out to be 1.7278 feet, which is again splitting a hair's difference between the canonical cubit, as it's been called. I would suggest that this is the origin of that and why it can be found in so many sites, let alone the numerical importance of it. But what I didn't point out was, well, this section of arc is 0.52066 meters, which is 27.3312 fingers, because you divide 12 thumbs is an inch, or 16 fingers would create. So that's fingers or inches, one of these difference. And that turns out to be 1.000899 Samian cubits. Samian, Doric and Ionic, as well as the allegedly modern English foot, can be found on a Salomon stone from ancient Greece. And if you apply that knowledge to various temples, such as the Parthenon, you get all these harmonic numbers. But this section of arc is a curve, okay? Now what we have is 52.066 centimeters. Now if we go to the unit based on the Mohenjo-Daro scale, the straight line across is 0.52066.109 mils. Now that's a difference of hundredths of a millimeter there. This is like splitting a split hair, then you have to split it again to get this difference. The straight line across here, in all, again above 99.9999999% is this length of arc here. So what we've now done is to turn this unit and we've made a straight line of it, which again, it's the same. The straight line here is equal to the curve here. So here comes the problem. So what we have now is, well, 1 meter, that length, that arc is 1 Egyptian royal cubit. Now that's a curved line. How do you translate that into a straight line? What you would need to do is take this pendulum and add 5.67 millimeters. If I add 5.67 millimeters to this, the straight line across would be pi over 6 meters. This all blends together. Okay. Now, what else is important about this? So here we have the pyramid. Okay, well, seconds per day. So this is an important number. 86,400 seconds per day. Here in white, I have the pyramid. Now, I've exaggerated these slightly. What we have is at the corners, we have what's called the sockets, and the pyramid itself sits on a 55 centimetre high paving stone. if I multiply this distance, including the sockets, by 86,400 seconds per day, I get the equatorial circumference of the Earth. Or in other terms, this distance, maximum visible distance, including the sockets, is the rotation speed of the Earth per second. If I multiply the height of the pyramid, including the paving stones, times 86,400, I get the polar diameter of the Earth. So that's... Now what's interesting is that this is a Royal Egyptian Cubit. This only describes the pyramid itself. If I multiply this by 440, I describe the pyramid. But if I want to find the Earth-based measure at 86,400 as in seconds per day, it is, I need to multiply this number by 440. So whether it's 440 ERC or 440, that's canonical cubit, which I'd like to call the Mohenjo-Daro cubit. Now the difference there would be 0.001 foot, which is 1/3 of a millimetre. Basically, not much more than is even less maybe. Yeah, that's about, well, 1/3 of a millimetre again. So this particular unit times 440 gives us the base of the pyramid, including the sockets at the corner, which scales it to the size of the Earth.
Apart from encoding the size of the Earth and Moon in relation to one another, the pyramid also has again another lovely interesting connection, and you have to think about that through the Egyptian Royal Cubit, the pendulum, and these other pendulums which also embody the second, and these units of measure connected to these very important people just bathed in the esoteric and the occult. But so if you take a pyramid's 3D, think of it 3D, so your maximum visible base, you'll see two sides of the pyramid. If you include the sockets, multiply that number by the number of seconds per day, 86,400, you get the equatorial circumference of the Earth. But the Earth is not a perfect sphere, it's an oblate spheroid, a little bit flattened at the top. So then we take the height of the pyramid, including the paving stones. So just like we include the sockets, we include the paving stones underneath the pyramid. They are part of the structure after all. And we multiply that height by 86,400, the seconds, number of seconds in a day, defined by the pendulum, which gives us an Egyptian Royal Cubit, which defines a pyramid. But we get the polar diameter of the Earth. So we're describing the whole Earth, and we're describing the Earth as it is, not perfectly, because if it was a perfect sphere, you would just sort of move those, they wouldn't have to do those different heights opposed to the maximum visible base. But seconds per day for pendulum, and again all these other lovely connections in regards to the pendulum and the margins of error between these different pendulums also embody the precise margin of error between these supposedly unconnected different units of measure. But at the very least, it's a great way of learning things. But then if you look at all the coincidence blending together so beautifully, so it's a storm, it's a symphony of coincidence is what it is. And there's conspiracy theory, but there's also coincidence theory. So let's examine the relationship between the size of the Earth and the Great Pyramid. This is the explanation which dominates, and so it's that the Great Pyramid is a scale model of one hemisphere of the Earth at a ratio of 43,200, and this is true, this is correct. Whether it was designed like that, let's put that to the side, but this is true. It describes one hemisphere or half of the Earth. So usually when it's repeated, it said it represents the Earth at 43,200. No, it only represents one hemisphere, and that in itself is very, very cool. However, there's another way to look at it, but what we need to think about is that, so there we see on the northern side the casing stones, and beneath them we see the paving stones. So there's another idea where we see the paving stones, and they're about 55 centimeters, which is a lovely conversion to 273. But there's another feature we need to think about to actually work it out. So to scale it to the Earth, it's not actually the pyramid that does so. You need to include, number one, the socle or the paving stones. That gives it a little bit extra height. And you also need to add what are called the sockets at the corner. Now here's the METRE, and then was it the I think it was the French engineers who took those measurements as well, but we see the sockets there at the corner. Now I'll get a better, I'll make more sense of it in a moment. But so we have the socle or the paving stones, which adds height, and then we have the sockets at the corner, which add length to the base. That's necessary to get whether it's 432 or 864. Now I've highlighted the sockets in color here so you can see where they are, and in yellow is the actual pyramid itself. So if we take the survey data, whether Petrie or Cole or anyone else for that matter, but they're just varying a fraction of an inch here or there. But so the total perimeter is 3,022.7 feet, or 921.31 etc. meters. That's the actual, just the pyramid itself, not including the sockets. That's the perimeter. We multiply that by 43,200, we get 39,800.979 kilometers. The equatorial circumference of the Earth is 40,075 kilometers, give or take a fraction, just rounding it off there. So we're 274 kilometers off. What you actually need to do is include the sockets to give that extra perimeter. So now in blue I have in yellow we have the pyramid itself, and it's not very close. It's very close, but it's still 274 kilometers off. But if we include the perimeter with the sockets, but then we come up against a problem, because the southwest socket doesn't match the general square created by the other three. It sort of extends out on one side, and on one side it's short. So that is something of a problem, because we would need, now would be a sort of a very wonky square, because this line would be coming down there at an angle, at a steep, not a steep, but a very noticeable angle, and then it would be along the bottom there on the southern side, going off as well. But this problem, especially if we think about the METRE, the cubit, and the second relationship, we can solve this. So, and not only solve that problem, but get it to the Earth. So we have a series, with the METRE, the cubit, and all the relationships therein, because as we'll see, like the pyramid itself is 440 cubits on each side, and it just so happens that when you get this in blue, including the sockets, and then divide that by 440, the cubit is now longer, but it turns out to be the cubit, or the arc, that's created by a 1 second pendulum at 3.3 feet, which is the ancient Indus unit, and then later the Saxon yard as well. So, but to solve that problem of the corner there, so firstly we have the original height. So the pyramid itself does not match the circumference, equatorial circumference of the Earth. It's 247 kilometers off. Now if we take the height of a pyramid, not including the paving stones, multiply that by 43,200, we get 6,334.67 kilometers. The polar radius is 6,357. So now we're off by 23 kilometers from the polar radius. Okay, if we include the height of the paving stones, 55 centimeters, now we come to 147.186 meters. We have added a little bit of height. If we multiply that by 43,200, we get the Earth polar radius within 1.4 kilometers accuracy, which now is much close. We've gone from, was it 24 to less than 2. And so these are the problems with the 43,200 model. Firstly, it's only describing a hemisphere of the Earth. On its own, that's not an issue. However, even to describe the hemisphere, it doesn't work. Or there is a big problem, and that is that southwest cycle, because it sticks out to the west and it's short on the south. That affects the perimeter, which you need to get the circumference. So again, it only describes half of the Earth, and that you have to, well, fiddle with it a little bit to get it to fit in. You have to ignore that socket and sort of imagine one that fits perfectly. Now, it's also inelegant in that it requires a top view, so you have to get the perimeter, which is like a bird's eye view, a square, that's two-dimensional, and to get the height you have to think of it as a triangle. But the pyramid is a three-dimensional object, and if you perceive it as a three-dimensional object and then include the pendulum 1 second cubit relationship, now it becomes very elegant. So the Great Pyramid is not a square and a triangle, it's a pyramid, it's three-dimensional. Let's think of it that way. That's the solution. Think of a pyramid as a whole. Think of the pyramid as a pyramid, as three-dimensional, and think of the Earth as a whole, not as a half. So instead of a flat piece of paper, now let's think about, we can just turn that piece of paper into a 3D model and think of it in 3 dimensions. The most you'll ever see of the pyramid is, well, that's standing. Let's assume they didn't have flying machines. You can see 2 sides of a pyramid, 2 faces. That's because it's 3-dimensional, not a triangle, not a square. It's 3-dimensional. And if we think about it that way, and let's look at another dimension, time, such as the 1 meter, 1 second pendulum creating an Egyptian royal cubit. So now we stand at the base and we include the sockets. So I'm looking at it from the northeast corner, and this corner fits the best, but also we're thinking of it in 3 dimensions. So that socket, which is on the opposite side, which we can't see now, doesn't pose an issue. And not only that, this corner directly aligns to Heliopolis, and it directly aligns to Heliopolis at precisely 100 times the base length of the pyramid. But 86,400 seconds per day. Now if we stand at especially the northwest corner, the one looking at Heliopolis, and that is at a lovely distance, and all the other connections to Heliopolis. So a diagonal straight through the pyramid points not only at Heliopolis, but at the sacred mound of Heliopolis as well. So if we think of it 3D, we look at it 3D, we stand there, get that measurement, the Heliopolis measurement, including the sockets, the rotational speed of the Earth per second, 463.83218 per second, and including the sockets, what's the length we see? 463.81289 meters. We're centimeters away from the perfect rotational speed of the Earth per second. So therefore, we multiply that number by 86,400, as in seconds per day, we get the equatorial circumference of the Earth. If we multiply the height, including the socle or the paving stones, we get the polar diameter of the Earth. So the Great Pyramid is a scale model of the whole Earth at a ratio of 86,400. It's only half Earth at 43,200. And it's just a more elegant system because it's a 3D object. We're looking at it 3D. We take those measurements and we don't have to fudge the corners on the south west on the sockets. And then we have the meter cubit relationship as well. But you know, that's what the 43,200 model is accurately describing. But even then, it's not accurate because we're ignoring the southwest socket, which doesn't fit, and it changes, and it's, you know, a small amount multiplied by either 43,200 or 86,400, whichever way you look at it. That discrepancy in the southwest corner it gets exaggerated by either 43,200 or 86,400, and so this is, in many ways, this is just more elegant and encodes more, such as the meter cubit second relationship. It actually works. We're looking at the pyramid as a three-dimensional object to create a three-dimensional object. The Earth is a sphere or oblate spheroid, and that's the beauty of it, because the pyramid at these describes the oblate spheroid, polar diameter and equatorial circumference. The Earth is wider at the equator, and it's a bit pushed down at the north and south pole. So we're overcoming all of the issues, and again we're using a three-dimensional object to get a three-dimensional object, connecting it with the second, and all these other features. So Great Pyramid is scaled to Earth at 86,400. There are 86,400 seconds per day, that whole meter cubit thing. Now there's another nice connection, so 86,400 seconds per day. The mean diameter of the Sun is 864,000 miles. Mean diameter of Jupiter is 86,400 miles, number of seconds per day. The orbital speed of the Moon is 86,400 kilometers per day. The orbital speed of Saturn is 864,000 kilometers per day. So this meter, the meter, the cubit, and the foot relationship as well. Now, I would say imperial, and as we'll see later, because if you think of it not as feet, but the relationship between the meter and the yard and the cubit, and distances between the inner planets, and the ratios of size between Earth and Moon, all starts coming in together. And that particular number, 27.3, is also found in the pendulum, in the pendulums as well, encoded in that margin of error. So 86,000, and there are other elements to 864 in regards to the Moon. I forget the exact one offhand, but the diameter of the Moon, I think it's in chain, but it's 864 as well. But this is, one connection draws off another, and that's not the only one. We have like 27.3. We'll get 29.53 as well, the number of days in a synodic month, and more info in that. But 86,400 seconds per day. All nice links connected through there.
The difference between the Egyptian foot and the English foot, 5.6 millimeters. 5.6 millimeters minus 1 meter gives us the official 1 second pendulum at 45 degrees north. 5.67 millimeters, 1/100th of a millimeter difference, added to this pendulum would make the straight line exactly this number. So now we've turned a curve into a straight line, and now we can create a ruler very, very accurate from that. And as it stands now at 3.3 feet, it is again within a thousandth or even more of a millimeter, the exact distance which forms this arc here. So these margins of error will lead to beautiful, beautiful stuff, and it's all based on measuring length, measuring time. Now what's also interesting is the Samian scale, which is on the Salamis stone, just like the Doric and the Ionic, the height of the pyramid, just the pyramid, is 27.335 Doric rods. What's a rod? A rod is 16.5 feet, or half of 33, 3.3. So this is so whether it's in Bible stories, New Jerusalem, the measuring rod, Nuafu, Ningashida, Hermes, Sheshet, Thoth, using measuring. They're gods of weights and measures. And what you have is a coming together of time, length, architecture, and because of the Earth, so 45 degrees north would be this pendulum, and as you move north or south of the equator, you would have to adjust your pendulum length to get exactly 86,400 seconds per day. And again, these apparently separate, because Mohenjo-Daro and Harappa, they used a weight scale where one of the key weights was 27.3 grams, which is exactly the same as the Old Kingdom copper Devon. The numbers which so the moon is 27.3% the size of the Earth. The moon orbits the Earth every 27.3 days in regards to a star. So much that's covered earlier, but it's just through the margin of error, especially there are a few these systems will link, and I'll link at very significant, very important numbers. And this is a type of stuff you can check it on your, double check it, look at the sources, check the maths for yourself. What we find, 5.67 mils plus this would create exactly one Egyptian roll cubit as a straight line across. 5.6 mils minus a meter equals 1 second pendulum. That's gone a little bit longer. That's why. Would create a 1 second pendulum at 45 degrees north. And also worth noting that this has to be 30 degrees. Anything more than that will affect the timing. Well, Giza itself, the plateau, is 30 degrees north. Now, the Great Pyramid is slightly short of 30 degrees north. And how much? Well, the base of Egyptian Royal Cubit times 440 equals the base of just the pyramid. Egyptian Royal Cubit times 4,400 equals the distance that the Great Pyramid is short of exactly 30 degrees north. Now, the 360 degree compass, we're familiar with that. There's also another radian, which is another way of measuring circles, the angles. It just so happens that 30 degrees is pi over 6 radian, and one Egyptian Royal Cubit is pi over 6 meters as well. So there's another lovely connection, because at 30 degrees you're at pi over 6 radian, you're 4,400 pi over 6 meters short of that distance to be to the very center of the Great Pyramid. 86,400 seconds per day times the maximum visible base and the height of the pyramid gives you the polar diameter, as well as the equatorial circumference of the Earth, rivaling until the most recent satellite age. So time, measure, architecture, these margins of error, instead of rounding off, if you look at these and apply these, it will just continually link and blend in to one another. And this is what, so especially if you're a global civilization with trade, think of the English Empire. They weren't using modern technology. They had to navigate, measure. Well, the same tools, that were basically, except for the telescope maybe, but were available to them. Tools such as this are exactly the ones that would have been available to an ancient global trade civilization, because the Mohenjo-Daro units of weight and measure correspond to the Old Kingdom, and also they link wonderfully with the Sumerians. We also see evidence of it in the Vinca culture, Varna culture of Old Europe in Bulgaria, which predate, which go back to 3500 BC. We find the Egyptian royal cubit in the Varna culture. The Varna hoarders was found in Bulgaria, which also incorporates the same geometry of the Great Pyramid in these golden tablets that they have, golden plates. So yes, there's still more to go with this, and I'm gonna, I need to create these videos, so I've got a basis. So we're using these as an example with some other still images and showing how the meter coincides with the Mohenjo-Daro or Saxon yard, come back to very important numbers, linking very important sites, essential architecture, legends, so it's all blended in there together. And of course, this can be measured, so that it needs to be. You pile up the coincidences, and the probability starts, extending out. The improbability of this being a coincidence starts mounting up and extending much further. So weights and measures, man is a measure of all things. The Great Pyramid is just one example. That what you'll find in the Great Pyramid is also in other sites. Now, okay, might as well mention, since I'll do a video on this, but Notre Dame Cathedral, what they found was a unit of measure which Stefan Lefringe called the royal foot. I'm going to call it the medieval royal foot, not to be confused. The medieval royal foot was essentially, within splitting hairs, 333 millimeters. So one medieval royal yard would have been 1 meter minus a millimeter, and that's within the margin of error. So this 1 meter pendulum can be found in Notre Dame Cathedral and Beauvais Cathedral and other cathedrals as well. Just as an example that this has been transmitted across time. And so, for instance, one of the early, when Mersenne and Riccioli were looking at this original 1 second pendulum, they were using this as a metronome to time the choir. So as the second as an important unit of time in many aspects as well. But Egypt, the allegedly modern foot and meter, as well as the Mohenjo-Daro units, if you look at them through the pendulum and the second, the arcs and the lines and the units just will describe all these different features and bring them together. And so what more can, so I'll be using this video as a background for some other upcoming episodes, because it sort of still relates back to what I've been working on in this particular series in the last few episodes, the importance of the meter and how it corresponds to the foot, and how that corresponds to sun, earth and moon inherent measures, as well as the cellular stones, same in Doric, Ionic, all comes together at these, especially 27.3 or 29.35, 29.35 days per synodic month or full moon. So yeah, measures of sun, earth and moon, measures of time via the pendulum, ancient units across ancient cultures. Just it's either, it was either designed, or it was the most extraordinary coincidence since creation, and that's about the only way you can really think of it. Because there is no, to say coincidence, or to say it doesn't happen, that it's impossible because we've made an assumptions on what was done. Well, this can be done with math, geometry, and the same tools that the medieval and Renaissance people were working with. They didn't have computers, they didn't have lasers, they had cross staffs, rulers, mathematics, and observation experimentation. And so pendulums, the second feet units, not just the English foot meter cubit, but also other units such as the canonical, Doric, and Ionic, all coming together. Earth-based geometry, earth measure. Geo is earth, metre is measure, otherwise known as geodesy. But there it is. Measure, the wisdom of Hermes, Thoth, Shesset, and these other gods of weights and measure, gods of math, though also the gods of architecture and astronomy. And well, what do you get? It all comes together: math, geometry, measure, astronomy, sun, earth, moon, the planets as well, as I covered in the earlier video as well. And okay, let's say it was a coincidence. Well, very well, but then here we have a method for encoding information that could be taught. It can be done, experimented at home with, and so at the very least, I think it's profound information in that sense. But I don't believe it's the synchronicities, coincidence just keeps building up to a point. Well, no, it can't be. It has to be designed because, for instance, 30 degrees is 108,000 seconds of the compass. So
again, 30 degrees being the maximum recommended angle to swing a pendulum. If you swing more than that, it will lose its timing, but 30 degrees, 60 minutes per degree, 60 seconds per minute, just like in the clock. So 30 degrees is 108,000 seconds of the protractor or the compass, which is at the very least a great memory tool, because for instance the orbital speed of the Earth is 108,000 kilometers per hour. Now there's also those relationships of Sun, Earth, Moon, also of Saturn, because the polar diameter of Saturn 108,000 kilometers. But again, just one of these, in religion, ancient architecture, modern architecture, the use of 108 just popping up over and over again, and giving not just in the, you could say, the man-made measures. That's a interesting point to ask, but also the proportions between the sizes. So for instance, the diameter of a moon times 180 is the distance from the moon to the Earth. The Earth diameter times 180 is the diameter of the Sun. The diameter of the Sun times 180 is the distance from the Sun to the Earth. Diameter of Saturn times 1080 is the distance from the Sun to Saturn. But so the pendulum gives us 1 second per day, 86,400 seconds per day. Main diameter of Jupiter, 86,400 miles. Orbital speed of the moon, 86,400 kilometers per day. Multiply the number of seconds per day and just Jupiter and the moon, you get Saturn, which is 864,000 kilometers per day orbital, and the mean diameter of the Sun, 86,400 miles. So 108, 864, again, just with these harmonic numbers, even just the way they divide up, at the very least it's a great memory tool. But even further, you could ask interesting questions, because again, it's a question of how these ancient units of measure, the architecture, the mythology, the symbolism, just ties in so nicely to systems of measurement, the fundamentals of science, and then also how these just so happen so nicely come to connect to these proportions: Sun, Earth, Moon, Saturn, Jupiter, and all these other ones. Now, the questions I can't answer, but so that's why I say at the very least it's a great memory tool. Because if you can create a clock and you know how to measure, you know how to do these things, the world is yours, my son, and everything in it.
Here we have a method for encoding information that could be taught. It can be done, experimented at home with, and so at the very least, I think it's profound information in that sense. But I don't believe it's the synchronicities, coincidence just keeps building up to a point. Well, no, it can't be. It has to be designed because, for instance, 30 degrees is 108,000 seconds of the compass. This also applies in so many aspects in regards to astronomy, speeds of distances, rotation periods of planets, etc. Yeah, okay. Have a good one.
Hello, SGD, Sacred Geometry Decoded. this series, actually throughout my whole channel, is based on ancient architecture, ancient metrology, especially connected to the quadrivium and hermetic knowledge, astronomy, geometry, arithmetic, and music, especially through weights and measures. Also how the esoteric world, or the occult knowledge, occult sciences, hermetic knowledge, such as that embedded in Freemasonic traditions and Rosicrucians and the early theosophists, who were themselves either geometricians, metrologists, astronomers, and so forth, blends together in a very wonderful way, and it's in a way that instead of on mystery of a big question mark, well, there are some very lovely answers in regards to this. By no means the complete story, however, through the geometry of the Great Pyramids, through the geometry of ancient structures, including the Parthenon or the stone circles in the UK, Ireland, Scotland, etc., how they all blend together in a wonderful way, which still defines modern architecture. So the great capital cities, whether it's Brasilia, Washington, Canberra, Astana, London, New York, or Paris, how the key points of architecture throughout those embed this same ancient codex of knowledge. Hermes, god of weights and measures. Thoth and Shesset, god of weights, measures, geometry, astronomy, architecture, and so forth. And so whether to weigh something or to measure something for its length, well, this will actually link to pendulums and measuring time. And time of the sciences is still pretty much one of the most esoteric, one of the most difficult, ethereal in a sense. And this is an important feature because the ethereal leads to the material, to the measurable, which will link to the ancient architecture and traditions across the world. If we begin with this pendulum, it is 1 modern meter long. I've just used the same graphic, so as you can see, but we'll be keeping 1 second depending on your position along the earth. But first, to focus on the pendulum of exactly 1 modern meter in length. Because all of these pendulums need to be swung less than 30 degrees, we'll be using 30 degrees, or pi over 6 radian is another way of measuring it. Therefore, a 1 meter pendulum, that 30 degrees of arc equals, by definition, pi over 6 meters, or 0.5235599. So now we have a meter at this 30 degree arc, creating a very, very effective 1 meter pendulum. However, all of these will individually contain important information. They will blend to one another to contain some very important information. And the first aspect of it is that a 1 meter pendulum at this 30 degrees, the arc of pi over 6 meters is equal to 1 Egyptian royal cubit, Old Kingdom Egyptian royal cubit, not to be confused with the later ones. There are many surviving cubit rods, and also by applying that to the architecture itself, so many examples of the cubit, not just throughout the Great Pyramid, but throughout all of the pyramids. You'll find it in Nilometers, you'll find it in other very important, very old temples of Egypt. And so this concept of 1 meter equals 1 Egyptian royal cubit equals 1 second. Measurements of time leading us to measurements of distance, or vice versa. So the Egyptian royal cubit of pi over 6 meters and the Great Pyramid. Again, this royal cubit is not isolated to the Great Pyramid. It is a defining feature of the main Giza pyramids, but we'll also see it in the Red Pyramid, the Bent Pyramid, and again other temples. Schwaller de Lubitz would be a interesting source in regards to this. He was one of the first to really bring forward the connection between the meter and the cubit. But now if we consider it in regards to time, well, measurement, so hertz, which is so important. Well, hertz is measured per second, and if we see the wavelength in meters, so 1 meter, 1 hertz is 299,792,458 hertz. If you're not familiar with that number, that's the speed of light number as well. So we have a very interesting connection between the second, the meter, and hertz, and how these application measurements of time, measurements of distance come together to give us very important tools, SI measurements, international standards. So we go, what is the modern meter? Well, the modern meter since the 70s has been defined by the speed of light per second. So we have a connection again to the meter, to a constant, and this is all about universal constants, geometric mathematical constants, which are being constant. They're universal truths in that sense. And so the meter and the second coming together to give us very, very important integral foundation stones of the science that we have now, and also pointing to these methods, these systems which go back in time. So just to focus on that 1 meter gives us one arc of the Egyptian royal cubit. Well, now the pendulum furthest to the right, and we'll explore this later, but the straight line between those pendulums now gives us an Egyptian royal cubit in a straight line. So we've turned a curve into making of a ruler. If you look at the survey data, for instance, the J.H. Cole survey of a pyramid, if you look at the base length, what we have is based on the average of the base length across the pyramid, it is ever so close to pi over 6 meters. It is 40 microns. It's the thinnest human hair difference. Another interesting feature in regards to the meter and the cubit is that if you add an Egyptian royal cubit to a meter, you get 4.99868 ... English feet. Again, such a small difference, where 1.52359 etc. is a meter plus a cubit. 1.524 meters equals 5 feet. Once more, we're splitting hairs in regards to the difference between these, and even over recent times the definition of them has changed ever so slightly, so to nail that down is very difficult. But 0.4 of a millimeter is the difference between 5 feet and a meter plus an Egyptian royal cubit, and the relationship between foot, meter and cubit, imperial Egyptian and the modern metric, but also how it all blend to other scales. Now, for instance, pi over 6 meters is 1.178 ... feet. This is a very interesting number in, well, many aspects, because essentially what it is equal to is E minus 1, or Euler's number minus 1. This again is a very important constant throughout so many aspects in chemistry, biology, banking, and as a natural rate of growth. So the difference there you can see between pi over 6 meters, and there in the blue beneath it we see the absolute value of E minus 1, which will bring us to this equation here, Euler's identity, which is said to be one of the most beautiful, if not the most beautiful equation in maths. This particular knowledge, which will lead us back to the pyramids, to the pendulum, to the meter, to the cubit, and the second joins up, because the difference between pi over 6 meters to feet and E minus 1 is a difference of 0.1335 millimeters. Again, such a small margin of error, which goes beyond the margins of error in surveying places such as almost anywhere on Earth, even a modern building, to get it to a fraction of a millimeter. Well, now here you see some examples of Euler's number, why it's so important. So biology, growth rates and interest, radioactive decay, temperature, electronics, probability theory. Well, this will also relate to the golden section of a golden ratio, or phi as it's called, 1.618033, well, etc. This again is another very important number which we see appearing in nature in so many different ways, from the micro to the macro. So back to the 1 meter pendulum gives us 1 Egyptian royal cubit. So we times the base of the pyramid times 440. We have an Egyptian royal cube. The base of the pyramid, we times that number by 280. We get the height of the pyramid. but also in regards to the ratio built into the pyramid. It doesn't matter what unit you use, but the slope to the half base will give you a very close approximate of the golden number. However, because the pyramid is not exactly perfectly square, there are slight variations, and these variations themselves incorporate some beautiful knowledge. But to begin with, we have the golden ratio in the Great Pyramid. Again, as I mentioned, each side has a slight variation. There's also the 8-sided pyramid, which gives you an indent, which changes the slope angle, for instance. However, if you incorporate these slight variations, including the indentation and the slight variation on each side, on the left we see the idealized measures of a pyramid, giving us the golden number to 99.96536%. If you include the variations and the actual measures of it, it brings it essentially to 99.9% and above. But we also have E, Euler's number in there, E times 100 built into the idealized. So the base divided by phi, 440 divided by phi, we already saw the phi ratio gives us E times 100. So we see a nice connection between the constant of E as well as the golden ratio, and how these blend together, and how one constant leads to another, one system of measurement leads to these constants, and how each of these measurement systems come together. We also, well, one Egyptian royal cubit is E minus 1 feet within human hair, but we also have Euler's number built into the proportions of E minus 1, I should say, built into the proportions of the pyramid itself above 99.9%. Again, if we incorporate all the slight variations, we'll get that to 99.9%, but Euler's identity, E to I pi plus 1 equals 0, one of the most beautiful equations, as they say, in mathematics. This has other important aspects to it, because plus 1 is a feature. So we already saw E minus 1 as a defining feature, as in feet per Egyptian royal cubit, and also you see E to the I pi plus 1 coming together. Well, we already spoke about the connection between E and phi. Well, this is one of the beautiful things about phi. Phi squared equals phi plus 1. 1 divided by phi equals phi minus 1. Plus 1, minus 1, these lovely, beautiful equations in which it's defined so much of nature and even our materialist world. So just a close-up of it again. Phi squared equals phi plus 1, 1.618 dot 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 plus 1 equals 2.618033, and or 1 divided by phi is phi minus 1. Beautiful mathematical connections. Now, in previous episodes in this series, I spoke about the sidereal month and the synodic month, and how they're embedded in the pyramid, part of this geometry, astronomy, arithmetic and music. Well, the number of synodic months per year, full moons per year, plus 1 equals the number of sidereal months per year. Another aspect of this lovely connection, Euler's identity, as it's said to be the most beautiful equation in mathematics. And the connections aspects are really in this. I've reviewed some stuff earlier, but we'll be seeing how these other pendulums ultimately connect in a beautiful mathematical proportions. So just to revise, we saw the proportion of the pyramid where the base divided by the phi ratio gives us E times 100. This aspect of times 10 times 100 times 1000 is another important feature, because we already saw Euler's identity in E. Now we also have the phi ratio, pi, being an important part of Euler's identity. And of course, the pi ratios in the pyramid are one of the most well-known in regards to this aspect, so E times 100. Now if you take the maximum visible base of the pyramid, so 2 bases, divided by the height, you get a very good approximate of pi. If you include again the slight variations, it gets even higher than 99.95977%, but just using the idealized for the moment. and it just so happens that the maximum visible base divided by the height, doesn't matter what measurement you use, will give us pi. The maximum visible base in cubits minus the height gives us 600 Egyptian raw cubits, or pi times 100 meters. Using the idealized measures, again, slight variations, but again, now we see the aspect of E times 100, pi times 100. How it connects with meters, how it connects with pure ratio, doesn't matter what unit you use. These are repeated themes where every ratio is repeated with mathematics. It's also worth noting that the southern base plus the eastern base of a pyramid equals, well, essentially E minus 1 times 1,000 long inches. And what is a long inch? That's an ancient unit of measure that Michael Parker Pearson has been promoting for some times, and has recently shown in what's called the Folkton Drums, that in the ancient UK, how these drums are a possible way of preserving these measurements simply by wrapping a rope around it. You have a unit of measure, so multiple units of measure, measuring length, connecting to measurements of time, specifically the second, and how these will all connect in together. So it's quite a bit more to come, because each one of these four pendulums has some remarkable maths, some remarkable metrology connecting them to all of the pyramids, all of the great pyramids, not just the Great Pyramid, but also ancient sites across the ancient world, which will embed mathematical constants, as in arithmetic, geometry, astronomy, and music, the quadrivium.